Hi everyone, welcome back to the City Reconstruction series. In part 1, we generated synthetic projections. In part 2, we reconstructed with filtered backprojection on a full 360 scan. Today in part 3, we are going to compare 3 types of scans: full scan, short scan, and overscan, and see how different redundancy weightings affect the reconstruction. In fan beam CT, every ray is defined by 2 parameters, the source angle and the detector angle. Because of the fan geometry, some projections carry overlapping information. If we just add everything up, we would double count parts of the data. That's why we need redundancy weighting functions, which decide how much weight to give to each ray before filtering and backprojection. Let's start with the simplest case, a full 360 scan. Here, every ray path is covered exactly twice. Once when the source is on one side, and again 180 later. The redundancy is uniform, so we simply assign each measurement half weight. This is equivalent to multiplying by 0.5 everywhere. The reconstruction looks clean and artifact-free. What if we don't collect all 360 views? It turns out you only need 180 plus the fan angle. This is called a short scan. But now the redundancy is not uniform. Near the ends of the scan, some rays are seen only once, while others are seen twice. To fix this, we use the Parker weighting function, which smoothly ramps up and down like wedges on the left and right edges. This ensures every ray contributes exactly once overall. With Parker weights, the short scan reconstruction looks just as good as the full scan. In practice, scanners often go beyond the exact short scan. Why? Overscans can improve image quality by reducing artifacts and noise. But if we apply standard Parker weights, we would introduce shading because the extra views would be double counted. Instead, we use a generalized weights. Here, the redundancy regions are split. This gives a mathematically exact and artifact-free reconstruction, even with overscan. So now let's go to the code. And I already using our previous generating of synthetic projections, I generated projections of our full scan, which is 720 views over 360 degrees. I also generated a short scan, which is exact 180 plus fan angle. This corresponds to 425 views. And I also generated an overscan, which is more than the minimum 100 plus fan angle. And here I use 280 degrees and with 560 view angles. And now I saved all my projection and view angle in a folder. Let's first run the reconstruction with full scan. And here in this code, we have the short scan weights. We also have the overscan weights. So now let's first run it on the full scan. And as it runs, I can show you the projections of the full scan. So the projection of the full scan is 720 view angles and 512 detectors. And here is the projection of the full scan. And let's wait until it finished reconstruction. And now let's next run the short scan, and then we can review the full scan reconstruction together as it runs. So let's reconstruct the short scan, which equals exactly 180 plus the fan angle. So now let's first review the reconstruction of the full scan. All reconstructed images is 512 by 512. And we can see it's a clean reconstruction. Now, as a reconstruction the short scan, let's also look at the short scan projection we generated earlier. So here is the short scan projection. It has 425 views with 512 detectors. And here is the short scan reconstruction. And we will review the short scan reconstruction shortly, but let's have it run on the Overscan reconstruction. And we also change this to over. So now let's also review the short scan reconstruction generated earlier. So here it is. This is 512 by 512. And again, we can see the Shep Logan Phantom was reconstructed clean and nice. And next, let's review the projection of the Overscan. And the projection of the Overscan has how many detectors? It's 560 views, okay? So it's 560 views and 512 detectors. So that is our Overscan projection. And now, since the Overscan reconstruction also finished, we can review the Overscan reconstruction. Oh, we should open it by 512 by 512. And here we see again a very nice and clean reconstruction without any shading artifacts. So all this indicates all our weights are applied correctly. So that's it for this demo. As you can see, the redundancy weighting is the key that makes fan beam filtered backprojection work. Whether you scan exactly 180 plus fan, a full 360, or anything in between. In the next video, we'll dig into more advanced reconstruction techniques. For now, I hope this gives you a clear intuition for how weighting shapes the final image. Thanks for watching, and see you next time.